All right, superstars, welcome. Sorry for this. I am at jury duty doing my civil service, trying to determine if anybody is innocent or guilty. Not too sure, but here we go. All right, turn to page 86, please, in your math workbook. Today we're going to be looking at grade 7, unit 2, lesson 11. And again, we call that lesson 7.2.11. Now, the last lesson that we did again was talking more about graphs, and we're going to continue with that understanding. It says interpreting graphs of proportional relationships. Now remember, our graphs, there's some key vocabulary that we want to work with. And our learning targets include, again, I can draw a graph. So we talked about plotting points. I can find the constant of proportionality. Remember, that's the k value. So what is k equal to? I understand the information given by graphs of proportional relationships that are made up of points or lines. So this is probably one of the biggest things and even the most challenging one. A lot of students are able to plot points, and then if they remember how to find the k value, because it's a little bit formula-like, but really trying to understand the information that is presented to you with that actual graph. That's the key idea. That's what you're needing to try and get understood fully before you move on to 8th grade and high school. All right, our coordinate plane. With your pencil, go ahead and make a quick sketch here again. It's just a big plus sign where we have our x-axis is the horizontal. We have our y-axis is vertical. I'll give you a moment to go ahead and try and do that. If you remember, the origin, the word that I had you write down the other day was the center. And that is specifically with our 0, 0. That's the center of the coordinate plane, which again is kind of like a circle here. You don't have to put that there. Some students like putting it there, but it's really just understood that the origin, the O, is the center, 0, 0. So that's where some students kind of remember it, is the zeros kind of look like the letter O. Origin is the center. It's always our starting point with our understanding with our graphs. All right, as we are continuing on. Let's see here, going down, going down, going down. Our warm-up. All right, so on the next page it says, what could the graph represent? So if you notice, you've got a graph over here that's already presented to you with a nice little dot. Before we do any further exploration, I'm going to remind you, with your proportional graphs that we're dealing with in 7th grade, go ahead and put a little dot at the actual origin, the 0, 0. That is great. All right, it says invent a situation that could be represented by this graph here. So really it's just trying to understand what scenario are you wanting to do. So some scenarios could be like maybe you're selling some tickets to a play, a school function, something like that. Maybe you're talking about traveling. So you got miles and distance, dealing with hours and things like that. You can talk about, one of my favorites again is dealing with pies, apple pie, cherry pie, things like that. So really just trying to think about it. What can these X numbers be and what could the Y numbers be? Now remember, one thing I did share with you almost every single time, that X is dealing with time. So if you'd like to, you can go ahead and say time and go ahead and write down what type of time are you talking about. We're talking about minutes, hours, things like that. I'm just going to go and do the nice minutes. So that's part B. Label the axes with the quantities in your situation. So start thinking about, again, what do you think? Your time is X. What could your Y be? Talking about the situation. Now, one thing that might help you with the situation is by traveling up the line. And remember, we're looking for good points to put a nice dot. Right here. So after 8 minutes, because again, the X is 8, 6 something happens. Now, if you think about like a mile run, 8 minutes for a mile run, some students can do that, but the 6, it's not 6 miles. So they definitely cannot run 6 miles in 8 minutes. So we're not going to put miles here. If you don't want minutes, you can change it to hours, dealing with something 6. Again, just trying to get you thinking a little bit more creatively. You could think about money. Well, money isn't really in minutes. That'd be hours. And 6. Hey, let's try this. What do you think about this? Let's erase this from minutes and let's change it to hours. Okay, H-O-U-R-S, hours. And for this one, let's go ahead and say, let me see if I can write it. We're going to say maybe pay. I'm trying to write it sideways. Meaning dollars. But 6 really doesn't make sense. But maybe we can say pay and then tens. Which really means the 6 is talking about 60, because 6 times 10 would be 60. So 8 hours, $60, talking about money. That might be okay. It's not quite even minimum wage, but it might be something. Now, again, if you have your own scenario, perfect. But let's keep traveling up the line. So again, we got 0, 0, 8 is the X, 6 is the Y. And then right here, they gave us another dot. I'm just make that a little bit darker. That's 16 and that's 12. You know, I'm going to go ahead and make a data table here. Let's do that as well. X, Y. So my first point, again, is 0, 0. 8, 6. So let's see. 8 is the X, 6 is the Y. And then as we traveled up the line again, we found this one right here. Looking down, that's 16 for the X. Looking over, that is 12 for the Y. And as we travel up the line, we don't have enough data there. Okay, so we're going to refer back to that actual data table in a bit. Give the graph a title. Okay, so let's talk about maybe something like take-home pay. Or we can say part-time job pay. So one word we can use is wages. But again, that's the scenario that I came up with. Maybe you came up with a different scenario. And if you kept mine, that's perfectly fine. All right, so let's see. Invent a situation. Check, we did that. Sorry about my dog, she's going crazy. Label the axes with quantities in your situation. Yes, there. Her name is Lulu. She is a almost 10-year-old golden doodle, kind of chunky. Give the graph a title. Definitely did that. There's a point on the graph. What are its coordinates? You know what? We already did that. Look at, I must have been psychic. But the data table 00861612, let's actually write it in the form of coordinates. So again, that would be in what's called an ordered pair, 0, 0. Remember, X, Y. Then the other one was 8, 6. And the other one was 12, 16. So for my situation again, 0 hours, 0 pay. 8 hours, $60, because remember, represents times 10, maybe. And then 12 hours, $160. So let's see, what does it represent in your situation? We talked about that pay. Let's go ahead and figure out what our scale, scale value, constant of proportionality. So 0, 0 is not going to be good. K is equal to Y over X. Let's use this one here, 8 and 6. Now remember, X is the 8, 6 is the Y. So we're going to say 6 over 8. And if you remember, I've taught you multiple times on how to break this up in case you're a little unsure. 6 can be a 2 times 3. 8 can be a 2 times 4, but 4 is a 2 times 2. Cross that off. K is equal to 3/4. Now, that's not really what we call a unit rate, but that is good practice right there. The unit rate is looking for the concept of per one. So it's kind of a side note. Here's our normal K constant of proportionality. K is equal to 3/4. We reduce that as much as we could. Unit rate, again, means per one. So if I have it as 6/8, I would actually just type it into my Desmos calculator. I would type in 6 divided by 8. And that gives me, off on the right here, 0.75. Because again, I'm not going to put it divide by 1, but 0.75. Now that's probably a little bit better for us, 0.75. All right, let's pause on there. Let's continue on. We talked about our information with plotting points, figure things out. So let's go ahead and discuss Tyler's walk. It says Tyler was at the amusement park. He walked at a steady pace from the ticket booth to the bumper cars. Let's go ahead and see here. You know what? They've got a nice data table set up for us. Let's go ahead and say this is X, this is Y. Notice how they're using different information, time and distance. X and Y, good for right now, but I think when we write our equation, we're going to be using time and distance. Sometimes it's, again, different letters, perfectly fine. All right, let's see here. The point on the graph shows his arrival at the bumper cars. What do the coordinates of the point tell us about the situation? So again, this is the point that they want us to focus on. So I'm going to go ahead and make it a little bit brighter there. Now again, the x-axis, time is 40 seconds. So it's having us look at this one, 40 seconds. The y-axis, distance from the ticket booth in meters. So it's asking us again, what does the 40, 50 from our coordinate point, our ordered pair, and our data table, what does 40, 50 mean? Let's go ahead and put a simple sentence here. Let's go ahead and type and you print. The point 40, 50 means trying to give you a little bit of time to think and catch up with your writing. The point 40, 50 means that Tyler walked for 40 seconds, which equals, I don't know if equals is the right word, which corresponds to 50 meters. Because again, the 40 means the 40 seconds, the 50 means the 50 meters. So while he was walking, our time is 40 seconds, our distance is 50 meters. Because sometimes when we are taken for a walk or even running or things like that, we would say, oh, I walked or I ran for 10 minutes. And then we can say, in that 10 minutes, I got this distance. All right, let's see. The table representing Tyler's walk shows other values of time and distance. Complete the table. Next, plot the pair of values on the grid. All right, so you know what? The table's already complete except for this one right here. So let's go ahead and plot our points. 0, 0, easiest one right here. Let's put 0, 0. 20, 25. So from the center, the origin, I'm going to go right 20 because remember that is talking about the x-axis and this is talking about the y-axis. So our time is x. So I'm going to go right 20, which refers to 20 seconds. I'm going to travel up to, and it says 25. So I'm going to go up to 20, pause, and if you notice, each box is vertically, talking about 5. So I'm going to go up one more box, which gives us 25. So I'm going to go ahead and label that 20, 25. Now we don't always do that, but I think it wanted us to. Let's see. Yeah, plot the pairs of values on the grid. So that's what it wants. It wants the point and the numbers. All right, 30 and 37.5. So from the origin, I'm going to go right to 30. Now, I think the 37.5 might cause a little bit of difficulty. So let's go up to 30. 35. Now, wanting you to think about, I'm obviously not going to go up to 40. So where do I need to travel up to? So if each box is 5, then the halfway would be 2.5. So if I go up halfway, that would give me the 37.5. So let's go ahead and write that as 30, 37.5. Which again tells us that when Tyler had walked 30 seconds, he had traveled 37.5 meters. The next one, again, was already done for us, 40, 50. That was pretty easy. So it looks like the last thing we have to do to find this part here, again, after traveling 1 second, is really our constant of proportionality. So again, k is equal to y over x. Now I'm going to go ahead and suggest this point right here. I think that's definitely the easiest one for us. So I'm going to go ahead and write it as my y is 50 over x is 40. Now, if you remember, we can cross off those little zeros there. Cross them off. 5 over 4. So k is equal to 5 over 4. But that really doesn't help us for this part here because, again, we're looking for it as per 1. We want the unit rate. So this, again, is a nice constant of proportionality. But a unit rate, I'm just going to go ahead and look at my Desmos calculator. I'm going to clear all. I'm going to type in 5 divided by 4. And that gives me a 1.25 for my unit rate. Which basically tells me for every second he walks, he's going to do a distance of 1.25 meters. So let's see. We did that. Check mark there. What does the point 0, 0 mean? Remember, that is the origin. That is our starting point. So let's go and put a little second or a little sentence there. We're going to go ahead and do our sentence starter of 0, 0 means. Now remember, the first number is our x, which is talking about the seconds, the time information. And the second number, referring to the y, is our distance traveled. So we're going to go ahead and say 0, 0 means Tyler walked for 0 seconds, which corresponds to 0 meters. All right, next part. It says, how far away from the ticket booth was Tyler after 1 second? Label the point on the graph that shows this information with its coordinates. Now, if you remember, on our data table, we already did that. It says 1 second was 1.25. Now, if you notice, it's a little bit hard to see, so I'm going to zoom in on the actual grid. Again, it's called the coordinate plane. We're looking at just quadrant 1. So if this is 0, this is technically 5, there's 10. So 1 second is just a little bit to the right. And again, if this is 5, so it's almost just like right there, like a tiny dot. Right 1 and then up 1.25, which is really hard to do when it's a scale of 5, meaning each box is talking about 5, 10, 15, 20, as I'm counting 5, 10, 15, 20, and so on. So again, that little tiny dot that I did, you're probably going to do it with your pencil as well. That's what they're really talking about. So let's go and put a 1, 1.25. I can even make that dot significantly larger because, again, it's not a true representation of it. But that's all right. Now, if we were doing online graphing, then that would be a little bit different. So how far away from the ticket booth was Tyler after 1 second? Well, we just talked about that. Let's see. After 1 second, Tyler was 1.25 meters from the ticket booth. So remember the origin, the 0, 0, the starting point, the beginning, that's where Tyler's journey started at the ticket booth. So that's what 0, 0 represents. So after just 1 second, he was barely, it's like 1 step, 2 steps maybe. Hey, we already talked about that, the constant of proportionality. So remember we said K is equal to 5/4. That was one version. Or we like the K equals 1.25. That's a little bit better. It says, what does it tell you about Tyler's walk? Where do you see it in the graph? Let's do an abbreviation real quick. The COP, which again stands for the constant of proportionality, means that Tyler walks for, maybe let's write it this way, walks 1.25 meters per second. There we go. That's a great way to say it. Because remember, the unit rate, really that word per there. And if you'd like to, you can go ahead and take your pencil and remind yourself per means division. And that's what we did here. 5 divided by 4 on the online calculator gave us the 1.25. There we go. Nice. All right. Again, feel free to pause it if the students need a little bit of time to actually catch up with the writing. Ready for more? Yeah, let's talk a little bit more. Okay. If Tyler wanted to get to the bumper cars in half the time, how would the graph representing his walk change? How would the table change? What about the constant of proportionality? Ooh, that's a little bit more challenging. Is there room for us to write? Yeah, let's go ahead and do that. All right, so let's make a quick data table again. X and Y. We know 0, 0 is the starting point. Now remember the end here is represented as 40, 50. So the distance is still 50. But it said if he wants to get there in half of the time, so instead of 40 seconds, we'd have to do half of the time, which would be 20 seconds. How would the table change? Well, we just kind of did that, 20, 50. We can find more numbers if we need to. Constant of proportionality, maybe we can focus on that part, and then maybe talk about the graph, what that looks like in just a moment. All right, so let's go over here. K is equal to Y over X, where Y is 50 divided by 20. Now remember, we go ahead and cross off little zeros. So K is equal to 5/2. Or let's do our decimal instead. So again, the decimal, I'll just bring up the calculator in a moment. But remember, the original was 5/4, which when I divided, it came out to 1.25. Some of you probably just know this in your head. 5 divided by 2. Do I got a glitch? There we go. I think it caught up. 5 divided by 2 and that gives us 2.5. So the constant of proportionality, if he wanted to get there in half of the time, the constant of proportionality doubled. So 1.25 times 2 gives us the 2.5. So how would the graph representing his walk change? So it would actually be what's called steeper. So imagine looking like this. You've got the X, you've got the Y. Your graph would actually come out steeper because he's walking faster. He's getting to his destination a lot quicker. Kind of like a car when it's driving faster, you get to the destination a lot quicker. All right, so let's do just a little bit on this one. And then if there's any time left in class, then you're going to try a little bit of the practice problems. All right, 4 seagulls ate 10 pounds of garbage. Ooh, gross. Okay, plot a point that shows the number of seagulls and the amount of garbage they ate. All right, so we got here 4 and then up to 10. There's my point. 4, 10. Plot a point that shows the number of seagulls and the amount of garbage they ate. Check, we did that. Use a straight edge to draw a line through this point and 0, 0. All right, so 0, 0 we know is right here. So what you're going to need to do is in your planner, you have one of those straight edges, a ruler if you will, note card, something. We want you to be able to connect it. So let me go ahead and see if I can bring up my shapes. Let's see. Use a straight edge to draw a line through this point and 0, 0. Kind of like that. Now that's not the greatest representation mathematically because on a point it means every single point is valid and you can't have half a seagull. But it's really just trying to visualize it. Plot the point 1K. So the reason they wanted you to do the line is to see where 1K is. Meaning I'm going to change my colors. If I go right 1, because remember that's the X, I'm going to travel up. And it's right about there. So that's 1K, which appears to be about 1, comma, and if you notice, it's kind of in the middle over here. So I think 2.5. Now, the way that I can verify that is, again, by actually finding the constant of proportionality. It's like another glitch, maybe. Check, check. Okay, not too sure. Sorry about that. Okay, we did this. We did that. What is the value of K? We just did that. What does the value of K tell you about this context? So let's make a quick sentence. The COP tells me that 2.5 pounds of garbage per seagull is eaten? Were they eating the garbage? Making the garbage? Now, one way that I can verify that again is going back up here. Let's just go ahead and put a quick K equals. K is equal to Y over X. Y is 10. X is 4. Let's see if the calculator will work. Let's see. 10 divided by 4. Yeah, look at there, 2.5. That's exactly what we were saying. So K is 2.5. So we actually found our constant of proportionality two ways. First way was by using the graph visually, which can cause some problems. The formula is always consistent. Now, the reason I say that the graph could cause some problems sometimes is it depends on the quality of students' lines, meaning if they don't connect the two dots very well, this line could be shifted a certain direction, and some students may have it like 1 and then it actually comes out to 3, or it might be even 1 shifted a little bit low, 2. So just be very, very careful when you make your lines. It's kind of like when we tried the Persian pet. We're going to try some more of that a little bit later where you plot the points and it makes a picture based off the quality of your lines. All right. I think we are going to go ahead and pause there. Again, if there is time left in class, which there should be, you're going to go ahead and try some of these practice problems. Now, you might need to end up using your Desmos calculator for this part here, just giving you a hint. You can try your traditional division, or if you have time, you can bring up your online calculator. But again, just try your best. It is in your textbook, just a few, or in your math workbook, just a few more pages next to it. All right, be awesome, guys.